Very excited to have you here. I have our guest speaker today is Isabel Garrido. You're from Spain. Is it Barcelona area?
Yeah, I live in Barcelona.
Okay. Excellent. And she is here to talk to us today about Kotlin Mutation Testing. Now, I'm going to admit I should have done more Googling ahead of time to find out all the details, but she's going to be telling us about it. So, I'm very interested to find out more. What do you want to say about Kotlin Mutation Testing?
Well, I have a lot of things to say about that. I hope you enjoy the talk. But the main thing that I wanted to tell you is that it's a it's something that we can use to be sure that we can rely on our test.
Cool.
So it's that's a really important thing, you know.
Oh yeah, yeah. No, I hate flaky tests. They're the worst thing. So, yeah. Why don't you put your slides up? We can take this away.
Yeah, sure. Okay. Uh, uh, uh.
Oh, and as a reminder to our viewers, if you put anything in the chat, you can ask questions, whatever. We can address them on screen here, so we can talk back and forth to each other and communicate. Here we go.
Perfect then. So, I'm really happy to be here today. Thank you so much for inviting me. I'm going to talk about a topic that I'm really excited about. But before that, I'm going to introduce myself a bit. The first thing you need to know about myself is that English is not my first language. So that's what happens inside my head every time I try to talk or to listen or to read or write. Um, But yeah, to tell you a bit more about me, I've been working for more than 9 years now as a server-side developer. Currently, I'm working in Set Code, but I've worked in a lot of companies before. The previous one was Letgo, and I love to share knowledge. That's why I have an introductory course to Kotlin in a platform known here in Spain called Kotlin TV. And I find mentorship to be a really important thing. So that's why I'm a mentor in Step Forward. It's a program that we have here in Barcelona where we try to help other women when they land the technical industry. Apart from that, in my free time, which is not much to be honest, I like to travel, I like to shoot, I like to take photos and spend time with my dogs. And here is my Twitter in case you want to reach out. So today we are going to talk about all those things that you can see here in the screen. So what's mutation testing, some common mutations, we will learn how to do it, how to use it, some advantages and disadvantages. We will compare mutation testing with code coverage, for example, and we will see a production-like example. But apart from that, we are in October, which is the spooky season. So we are going to talk about mutants, we are going to see how to kill them, and we are going to visit some graveyard. To introduce this topic, I like to use this tweet. So imagine a monkey shaking trees in a forest. Everything that falls from a tree should be checked. But let's be a bit more serious. Mutation testing is a technique to measure the reliability on our test suite, which consists on performing small changes in our application code and then execute our test suite to see how much of these changes or mutants we can kill. To see an example or a small change, I have some code here. So imagine that this is the original code and we do this small change. We change this less than for a less than or equal. So this is the kind of change that will happen with mutation testing and is what we know as a mutant. A mutant is a small change in our code, but is based on well-defined operators, like division by zero or incorrect comparison operators. And to kill a mutant. So to kill a mutant, we need at least one test to fail when the mutant is there. That's the short explanation. But a bit more deep explanation involves a model called RIP. which stands for reachability, infection, and propagation. And I'm going to try to explain you these three things with the example that we saw before. So reachability means that we need to have at least one test that reaches the code with the mutant. In this case, means that we need to have at least one test that calls the execute function. Infection means that we need to have at least one test with the data input necessary to reach the mutant. So in this code, we will need to have at least a value size which is greater than 0. And propagation means that there is some effect that we can check in our test. Some different result or some exception, something like that. In this code, we will have it because if we try to access a non-existent position in the array values, this will throw an exception. And now that I present you the basic parts of mutation testing, I want to talk you about the two primary reasons why it came out. So the first one is the competent programmer hypothesis. This tells us that a programmer with, or a developer of course, with experience tends to perform small syntax mistakes. And the second one is the coupling effect. So when we perform these small errors, they can become a big thing, a big system failure. So in short, every one of us can make mistakes. Mostly those mistakes will be a small syntax error, but those small errors can become big failures in our system. And now that I just introduced you the topic, I want to show you some common mutation operators. One is the conditional boundaries operator, which replaces the operators that we have here following the table. So a less than will become a less than or equal. This maybe it's similar to what we saw at the beginning, okay? We have here the less than, and here we have the less than or equal. So this mutant is created based on the conditional boundaries operator. But we had more. The negate sorry. The negate conditional replaces all the conditionals operator following this table. An equals will become a different, and for example, a less than will become a greater than or equal. If we want a new mutant for our original code, we could change our less than for a greater than or equal. Another operator will be the void method call, which removes any call to a method that returns void or in case of Kotlin unit. So, for example, we remove this printer.execute call and we have a new mutant here. The empty returns operator replaces any return value with an empty value according to the table. So if we return a string, we will return an empty string. If we return a list, an empty list, a map, an empty map, and int, short, long, float, or double will become a 0. Here we have a completely different original code where we have a list, we do something with the list, and then we return the result. So the mutant will return only an empty list. The true returns replace Boolean return values with true. In this function, we return if a number, if an int, is a multiple of any other int. So the mutant will return always true. If you want to know more information about it, I have a document in a repository that I can share with you, and you will see all these examples and how to kill these mutants. But to finish with this part, I wanted to mention extreme mutation testing, which is a technique that appears some like in the last years and consists on removing the behavior inside the function and just leaving the return according to the signature of the method, which is pretty similar to what happens in the empty return operator and in the true return operator. And why this is interesting? Well, because as we have less operators, we generate fewer mutants. With fewer mutants, we generate fewer duplicated mutants, and that decrease significantly the execution time and require fewer resources. And now maybe you think, okay, this is really nice, how I can use it, how I can do it. I really discourage you to do it manually because there is tons of work and it doesn't make any sense. In case of Kotlin, as we can use any library in the Java ecosystem, we can use a well-known library in the Java ecosystem, which is PyTest. This will take care of everything. This will generate the mutants. This will execute the test suite every time that a mutant is present, and will record all the information and prepare a report that we can read and that we can use to improve our test. And how we can include it in our project? Well, if you use Gradle, in my case with Kotlin, you just need to add this to the plugins part, to the plugins section. And I'm going to show you how to configure. So here we have two properties that we need in case we are using JUnit 5 for our unit test. This property, the target classes, is required because if it's not present, PyTest will not know which code needs to be mutated, okay? The output formats, it's optional, but I really recommend you to use the HTML one because it's easy to read and to understand. And the two last properties are related with the performance. So we can define the number of threads that we want to dedicate for the execution of PyTest, and the with history will allow us to perform incremental executions, and it's really useful if we execute mutation testing with PyTest in our local machine. In order to execute it, we just need to write Gradle PyTest, and that's it. And now that we know how to do it, let's going to see some advantages and disadvantages. But before going to the advantages, I wanted to ask you a question. So, what's the goal of doing test? We do test for a lot of reasons. To check behaviors, to reproduce bugs, to document some other behaviors, but mainly to be sure that we do something, and in the future, if we need to update the code or change it, we will be sure that everything is working if the tests are passing. So to summarize this, I found a quote in Wikipedia that I really like that says that tests are created to verify if an implementation is correct, but also tests are code and they can be incorrect or insufficient. So that's the advantage of mutation testing. It will allow us to forget things, and it will say to us, hey, you forget this, and we can take care of it. At this point, maybe you are thinking, why is not everybody using mutation testing? I hope so. Well, it has disadvantages. The, the execution time mainly and the resources required. Now we have libraries like the one I mentioned before, PyTest, that help with that, but in the end is something that we need to have in mind. I want to show you some execution time examples. So for a medium-sized project, the first time that we execute mutation testing, it took this amount of time, more than 15 minutes. And it required 201% of CPU. But it's really small project. It took 8 minutes and 40 seconds. Instead of the test execution plus code coverage, which in the first medium-sized project took a little bit more than 9 minutes, but in the smaller size project, it took 1 minute and 38 seconds. So I introduced you this term, code coverage. Maybe you are familiarized with it, but I'm going to explain a bit. Code coverage is a well-known and spread measure to know the percentage of lines of code covered by tests. And the first reference to this term is from 1963. Maybe this measure sounds good enough to know that we are a reliable test suite, but it has a big con. There are some books that says that a project has a good quality, is good quality if the code coverage is over 80%. And what happens when a metric, which is code coverage, becomes a target, which is this 80%. So Goodhart's law says that when a metric becomes a target, you fool it. So what tends to happen is that in projects where a fixed percentage of code coverage, the developers learn how to trick the coverage. And now it's time for a spooky story. So my team inherited a project from another company that set a goal of code coverage to 80%. We were naive and believed it was safe to make any change if the test suite was green. And then one day we deploy a very important change to production. Well, you can imagine what happened. It was a complete disaster. Stakeholders were mad, the system went down. Really bad. So obviously we roll back the change and take a deeper look at the test classes. And to our surprise, we saw a lot of tests without asserts or with asserts like true equals to true. We realized our mistake and removed all the tests that didn't bring value to the project and added some integration tests to cover the main flows. The image that you see here is the current state of the code coverage for this project. It's not a high value, it's not the 80% that the book said, but we can be sure that nothing is broken if the tests are passed. Can we? One day, I decided to execute mutation testing over this project and I found out this. Only the 23% of the, we only have the 23% of the mutation coverage. And it really hurt me. But why is this different? Why this number is so different from the line coverage? Well, because while code coverage measures the percentage of lines of code covered by tests, mutation testing measures the percentage of behavior covered by tests. And now I want to show you a production line example to finish. So it's a production-like example because the actual project in production is from my company and I cannot show you it. But I created a demo project configured exactly the same as we are using in the project. The first thing that I wanted to show you is this screenshot from one of the pull requests that we had in the project. At this point, I hope I convince you how useful is mutation testing. But I also wanted to mention that it's better to include it as a regular daily technique, as something that happens regularly. You work with it, you learn, you improve, than something that happens every now and then. And to be able to have this summary here, because it's not more than a summary, I created a GitHub action that we are going to see now. This one, okay. It's available in GitHub. It's public. You can check it. You can try it. And here in the README, there is all the requirements that you need, all the configuration that you need to have in your project, how you can use it in your GitHub Actions workflow. And I also have an example of a pull request where I am adding this step, which is this one. You can compare with the documentation that I have here. You can check it. And I'm going to show you. Those are the messages that the action leaves. As I was saying, it's a summary. It doesn't give you a lot of information, but as it says here, and we are going to see it now. So here in the artifacts part is uploaded the report, the HTML report, if you have it configured, that includes all the information that we need to understand better, where we need to improve our test suite and everything. You can download it and check it, and we are going to see an example. So here's the index. When you just open the documentation, here is what you will see. The first section is a global overview, in this case of the whole project. We can see the code coverage, we can see the mutation coverage, and we can see also the trace strength. And about the code coverage, well, the green part, of course, is the mutants that are killed, and the red part are the mutants that are not killed. But if we want to know more, if we want to see a bit of a detailed explanation of everything, we can go, and in this case, we have here all the classes involved in the project. We can see that two of these classes have all the mutants killed, but we have here one that is in red with one mutant not killed. Here we can see a list of all the active mutators that were used in this project. Some of them I mentioned to you, some of them not, because there are, like you can see, there are a lot. But these mutators are available for the whole project. And this is the most interesting part. So you can see here this line in red, which is the one with the mutant that is not killed. And here we can see an explanation on what mutant was here generated, and more or less that's it. Here we have below the same explanation. It's really useful when you have bigger projects and bigger files, and you can see that the reference to the line, and yeah, that's it. To finish, sorry. just a quick recap of all the things that we saw. Those are the key points that I want you to take from this talk. So tests are code, so they can be incorrect or insufficient. Mutation testing is a technique to know the reliability of our test suite. Code coverage is way faster and require fewer resources, but is really easy to trick. And it's more useful to introduce mutation testing on a regular based development process than as a one-time occurrence. If you want to know more, I leave you here all the resources. I will share these slides in case anyone is interested. I have here all the resources that I used, and that's it. Thank you so much for your time, and I hope you enjoy the talk.
Okay, so let's take some questions from the audience here. Just to recap, if you are just joined or whatever, the chat for the event stream is actually stuff we can get here and we can reply and show it on screen. So feel free to send us some questions in chat. Yeah, thank you. I'm excited to try that. Never heard of this before, so it's very interesting.
Yeah, it's really, I mean, it really gives you a lot of valuable information. And at the beginning, it's a little bit tricky to start, but once you have it running, I mean, it's great.
Mm-hmm. Nice. Getting a lot of applause in the chat at the moment. I don't know if anyone has a question. Yeah, I've been seeing a lot of very new, interesting testing going on, like screenshot testing with paparazzi. It's a big deal right now in the Kotlin community. I don't know if you have had a chance to mess with that one yet or not.
No, not with that.
So what some people will do is when they're writing Jetpack Compose for their Android apps, they'll turn their previews into something that executes and generates a screenshot, but it's doing it without an emulator, so it can run in the JVM entirely, and then it can compare the screenshot to see if it changed, and then you can automate sending that to your designers or other developers to verify if it's a correct change or not.
Yeah, that's
So
really cool.
yeah, very neat. Well, we'll take some questions now that we have some. I'm going to take the
Okay.
first one here. There we go. David Holmes asks, how reliable is this mutation testing process? Does it generate false positives and false negatives into evaluation of the test suite?
Well, in case of Kotlin, it generates false mutants. Okay, because as I was saying, PyTest is designed to work with Java, and Kotlin does some magic that in Java it's code. So PyTest try to mutate that code. Actually, there is a plugin, but I didn't have the chance to test it. Focus on using PyTest for Kotlin. What I actually did to decrease the number of not useful mutants in our project was to add a property that I can share with you. I don't know where I have it, but you can set another thing in the configuration of PyTest, and it will avoid to mutate some code.
Expecting a screen share.
No, wait, I'm checking. Yeah, I have here. But I cannot show you this. So I'm going to.
Is this share networking or?
Yeah. I mean, I'm doing it. Sorry,
Right.
it's because it's in the project that I cannot show you. So
Oh,
uh,
okay.
you need to set it this property avoid calls to, and this will decrease a lot the percentage of mutants that it doesn't make sense.
Nice. Awesome. We have another question here from David Lepic. He's a local in the Twin Cities here. He says, I see how mutation testing is much more useful in code coverage targets, which ignore cyclomatic complexity. That said, how do you handle heuristics? I have an arbitrary cutoff constant, so I don't care whether I'm using less than or less than equals. Okay.
Yeah, that's a thing that you need to live with. I mean, even in other languages where they have also tools, there's a huge disclaimer that says, okay, this will generate things that you don't care about. But I mean, if you want to use it, you need to pay this price.
Nice. Any more questions before we finish up here? By the way, Kotlin Conf is going to be happening this year. It's been 2 years off. It's going to be 2023 in mid-April in Amsterdam this year. So I'm really looking forward to that. Hope a lot of you all get to go.
Yeah, I hope so.
Let's see. Get a lot of applause. Steve Peterson said excellent presentation.
Thank you so much. I really appreciate everything.
Do the chat overlay here. Oh, there we go. Ah, new comments. It's like if you're not using these tools. Okay. I guess that must be all the questions for now. Thank you so much. It was great having you on, and I'm excited to give this stuff a try.
Yeah, I mean, let me know if you tried, and if you have any question or anything, you can reach on Twitter, and I'm happy to answer anything and try to help you as much as I can.
Cool, cool. Thanks so much. Yeah, another thanks for an awesome talk. I totally agree. It's been great. Yeah, I saw that already. Okay, so thanks so much, everybody. We're going to be back hopefully in another month and not wait a year between speakers. But yeah, it's been great, and I'll see you all next time. Thank
Bye.
you. Bye.